Hello friends, I am Balaji Rao from the Masters PU College. In last class, we completed exercise number 4.4. In this class, we are going to learn theory part related to exercise number 4.5. To understand this class, you must be good in what is minor of an element and what is cofactor of an element. In last exercise, completely we discussed about minor and cofactors only. I hope by this time you are good in what is minor of an element and what is cofactor of an element. Okay. You see this adjoint of a matrix. Definition: adjoint of a matrix. The adjoint of a square matrix is defined as transpose of cofactor matrix. The adjoint of a square matrix is defined as transpose of a cofactor matrix. I'll explain this while doing example. Transpose of cofactor matrix is called adjoint of a matrix. You see here a point. The adjoint of a matrix A is denoted by like this: ADJA. ADJA means adjoint of A. Okay. Here I'll try to explain this definition in this example. See here, they given A, the matrix A. They are asking to find adjoint of A. Adjoint of this matrix we need to find. What is adjoint of a matrix? Adjoint of a matrix is transpose of cofactor matrix. See, transpose of cofactor matrix. We know that this is first row, first column element. Its cofactor is denoted by capital A11. This is first row, second column element. Its cofactor is denoted by capital A12. What happened here? These elements cofactors I written. If I transpose this matrix, transpose of cofactor matrix is called adjoint of A. I hope you got some clarity about this definition now. What is adjoint of a matrix? Adjoint of a matrix is obtained by transposing cofactor matrix. So, to find adjoint of this matrix, first I need to find cofactors. In last class also, we learned how to find cofactor of an element. See here, this element is in first row, first column. Its cofactor is denoted by capital A11. This element is in first row, second column. Its cofactor is denoted by capital A12. This element is in second row, first column. It is denoted by, its cofactor is denoted by capital A21. Its cofactor is denoted by capital A22. Here I will tell you a trick. In earlier classes I explained as per the definition, but here I will tell you a trick here. Simple thing. Here 1 plus 1. You see here 1 is there now. 1 plus 1 is even number. 1 plus 1 is 2. 2 is even number. When even number is there, you write plus. You see here A12. You add these two numbers. 1 plus 2. 1 plus 2 is odd number. When odd number is there, you write minus. Why? Because while calculating what is the formula for cofactor? Minus 1 whole power I plus j into minor of that element. Na? Minus 1 whole power I plus j. Minus 1 whole power odd number is minus. Minus 1 whole power even number is plus 1. Why to think all those things? Simple thing is, here A12, 1 plus 2 is 3. 3 is odd number. When odd number is there, you write minus. See here A21, 2 plus 1 is 3. When 3 is odd number, when odd number is there, you write minus. A22, 2 plus 2 is 4. 4 is even number. When even number is there, you write plus. After writing signs like this, you need to write its minor. What is the minor of this element? Minor of this element is the determinant obtained by deleting first row, first column. You see, this is the example. Na? Delete first row, first column. Determinant of 4. Determinant of 4. Determinant of 1 by 1 matrix is what? The same element. So, plus 4. Right. Now, A12. What is this minor? What is the minor of this element? Minor of this element is the determinant obtained by deleting first row and second column. See here, delete first row, second column, determinant of 1. I hope you are understanding, right? Now, what is the minor of this A21? Is the determinant obtained by deleting second row, first column. Delete the second row, first column. What you got here? 3. Determinant of 3. right? A22. How you will get the minor of this element? Minor of this element is the determinant obtained by deleting second row, second column. Delete the second row, second column, determinant of this. I hope you are understanding, right? See here, plus is there, determinant of 4 is 4, so finally we got answer 4. Minus is there because this odd number is there, determinant of 1 is 1 only, so final answer is minus 1. Minus because of this sum is odd, determinant of 3 is 3, so our final answer is minus 3. What happened here? I calculated cofactors of all these elements. You know how to calculate cofactor of elements. Last exercise, complete exercise is about minors and cofactors only. Now what I'll do, I'll write cofactor of 2. What I got cofactor of 2? 4. I'll write cofactor of 3. What is cofactor of 3? Is minus 1. What is the cofactor of this element? That means 1. What is the cofactor of 1? That is minus 3. And cofactor of 4 is 2. I written cofactors. If I transpose this matrix, I'll get adjoint. See, transpose, how to transpose? You write first row as first column. You write second row as second column. That's it. You know how to find transpose of a matrix. We learned this in Matrices chapter, right? So if A is a matrix like this, then how to find it adjoint matrix means this is the actual method. We have a trick here to write this answer directly in a single step that I'll explain in a note. See here, this is the matrix A. They given like this. They are asking adjoint A. This trick works only for 2 by 2 matrix. Okay. So how to calculate adjoint of this matrix? Very simple. You interchange these two elements. Please observe here. Interchange these two elements like this. DA. Here AD is there. Na? You interchange DA. And change the sign for remaining two elements. Here plus B is there. Na? You write minus B. Here plus C is there. Na? You write minus C. In that way, for 2 by 2 matrix, by seeing the question itself, directly you can write what is adjoint of the matrix. This is not a shortcut. You can use this in PUC. This is mentioned in NCERT textbook. Okay, so here you see this example. This is the matrix A. Now, what is adjoint A? You just interchange these two elements. Look here, 4, 2. Here 2, 4 is there. Na? Interchange here 4, 2. Now change the sign. Here plus 3 is there. Na? Minus 3. Here plus 1 is there. Na? Minus 1. Like that, for 2 by 2 matrix, calculating adjoint A is very easy. This trick, what note I explained here, this trick doesn't work for 3 by 3 matrix. This trick works only for 2 by 2 matrix. What we learned till now in this class, we learned about adjoint of a matrix and we considered one example to understand adjoint of a matrix, right? What is adjoint of a matrix? Adjoint of a square matrix is defined as transpose of cofactor matrix. Now, to understand this more clearly, I'll take one more example of 3 by 3 matrix and we'll calculate its adjoint. You see, they are asking like this, find adjoint of this matrix. They are asking to find adjoint of this matrix. Okay, first what I did, I considered this matrix as A. Okay, what is adjoint of A? Adjoint of A is transpose of cofactor matrix. You observe here, transpose of cofactor matrix. See, this is first row, first column element. Na, its cofactor is denoted by capital A11. This is second row, second column element. Na, its cofactor is denoted by capital A22. Like that, all these elements cofactors. And if I transpose that cofactor matrix, I'll get adjoint of A. In last class, to calculate cofactor, I just followed the definition method. But another easy thing is there. What is that? First, I'll write like this. A11, A12, A13, A21, A22, A23, A31. All the cofactors I'll write first like this. Okay. Afterwards, see here. A11, 1 plus 1 is 2 na? 2 is even number. Even number means plus. 1 plus 2, odd number. Odd number means minus. 1 plus 3, even number. Even number means plus. 2 plus 1, 3, odd number. Odd number means minus. 2 plus 2, 4, even number. Even number means positive. 2 plus 3, 5, odd number. Odd number means minus. Like that, when we add these two numbers, if we are getting odd number, we'll write minus sign. If we are getting even number, we'll write plus sign. Like that you write. Or else simple thing, first write these order and plus minus alternate symbols. You can look here. First plus minus alternate symbols are there. Plus minus. Observe these cofactor elements. First you write like that. After writing this plus minus alternate symbols, you write minor of this element. Minor of this element is the determinant obtained by deleting first row first column. In this question, delete the first row first column. Delete the first row first column. Determinant of this, determinant of 3501. I hope you are understanding. Okay. Now here this minus, I already explained why we written this minus. Now you need to write minor of this element. Minor of this element is the determinant obtained by deleting first row second column. Delete first row second column, determinant of 25 minus 21. I hope you are understanding, right? Now A13, minor of this element is obtained, is the determinant obtained by deleting first row third column. Delete first row third column, determinant of 23 minus 20. Like that. See, A23, minor of this element is what? Minor of this element is the determinant obtained by deleting second row third column. Delete the second row third column. Second row third column you delete. Determinant of 1 minus 1 minus 20. 1 minus 1 minus 20. I hope you are understanding. Like that you write all its minors. Okay. Now let's simplify this further. You know how we got plus symbol here. First I written these symbols only. Later I written its minor. Why I am doing all these things? Because we know the cofactor definition. What is the cofactor definition? Minus 1 whole power I plus j into minor of aij. That is what I written. It is important to do these problems. You must be good in last exercise. Okay. Now what I'll do, I'll simplify. Here plus is there, no need to write this. You expand this 2 by 2 determinant. 3 into 1, 3 minus 0 into 5, 0. That is 3. Okay, minus, here you have to be careful. Here minus is there, na same minus I written here. Now expand this determinant. 2 into 1, 2 minus 2 into 5, that is minus 10. Minus of minus plus. 2 plus 10 is 12. So total this is minus 12. Like that all these things, determinants you need to expand. See here, plus is there, na? So no need to worry. 2 into 0, 0 minus 2 into 3, that is minus 6. That is 0 plus 6 is 6. 2 plus 1, odd number, that's why minus sign. Here this minus as it is. Now expand this determinant. Minus 1 into 1 is minus 1. Minus 0 into 2 is 0. If you simplify this, you are getting plus 1. And plus is there here. Expand this determinant. 1 into 1, 1 minus 2 into 2 is minus 4. Minus of minus plus 1 plus 4 is 5. Like that you expand, because from the first exercise onwards we are calculating these determinants of 2 by 2 matrix and determinant of 3 by 3 matrix. Like that you expand all these things. Now what I'll do, adjoint. What is adjoint definition? Adjoint of a matrix, a square matrix, is obtained by transposing the cofactor matrix. Transpose of cofactor elements. See here, A11. What is A11 you got here? See, A11, 3. A12 is minus 12. A13 is 6. 3 minus 12, 6. Like that. A21. What is A21? See here, A21 is 1, 5. 2, 1, 5, 2. I written respect to cofactor elements. What is third row first column element cofactor? Minus 11. Third row second column element cofactor? Minus 1. Third row third column element cofactor? 5. We need to transpose this matrix. Transpose this. You write first. How to transpose a matrix? You know from Matrices chapter. You write first row as first column. You write second row as second column. You write third row as third column. So whatever you got here, that is the adjoint of given matrix. This is little lengthy, but what we are calculating in this example, we are calculating adjoint of a matrix. In next exercise, in previous classes I said in 5th exercise one 5-mark question is there, not from the 5th exercise. In Determinants chapter, from 6th exercise one 5-mark question, 100% guarantee. In all those 5-mark questions, we will calculate adjoint of a given matrix. So it is important. You must be good in how to calculate adjoint of a given matrix. Okay. Till now what we learn in this class? We just learned what is definition of adjoint of a matrix and how to calculate adjoint of 2 by 2 matrix, how to calculate adjoint of 3 by 3 matrix. Okay, now very important theorem in this exercise. We use this result very frequently while doing objective bits. You see here, if A is a square matrix, then A into adjoint A equal to adjoint A into A equal to det A into I, where I is the identity matrix. Okay, now we need to prove this result. What is A? A is any square matrix. So what I'll do here, it's not a proof actually, it's just verification method. Square matrix means I can go with 2 by 2 matrix, 4 by 4 matrix also. Just simply I'm going with 3 by 3 matrix. You know, in Determinants chapter, all theorems will verify with a 3 by 3 matrix, most of the theorems, right? So here I consider A as a 3 by 3 matrix like this. This is general matrix. This is the element present in first row, first column. This is the element present in first row, second column. This is the element present in first row, third column. This is the element present in second row, first column. This is the element present in second row, second column. Like that, you know how I consider this general matrix. I need adjoint of this matrix. What is adjoint of a matrix? Adjoint of a matrix is defined as transpose of cofactor matrix. See here, its cofactor is denoted by capital A11, its cofactor is denoted by capital A32, its cofactor is denoted by capital A33. I written all these elements cofactors, and if I transpose this matrix, what I'll get? I'll get adjoint of this A, right? Now, as this is the general matrix, I'll transpose this matrix. How to transpose this matrix? You write first row as first column, second row as second column, third row as third column. You see here, you write first row as first column, second row as second column, third row as third column. So we transposed this matrix. Now you know A and you know adjoint A. What they are asking in this theorem, we need to show that A into adjoint A equal to det A into I. Okay, A into adjoint A. See here, the matrix A into adjoint A. First I'll write matrix A. Adjoint A is there here now, that A I'll write. In Matrices chapter, you know how to multiply two matrices. Okay, it is must. I cannot explain that how to multiply matrices in detail here. Please go through that matrix multiplication. Okay, how to multiply here? First row, first column. Corresponding elements you multiply and add them. A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13. First row, first column is over. Now first row, second column. Corresponding elements you multiply and then add them. First row, third column. Like that. Okay, now how you will get this? Second row, first column. How you will get this? Second row, second column. How you will get this? Second row, third column. How you will get this? Third row, first column. How you will get this? Third row, second column. How you will get this? Third row, third column, right? You know how to multiply two matrices. In Matrices chapter we learned, that is important in Matrices chapter. Okay, in last class we learned one important property related to determinants. Determinant can be evaluated in three methods. First one is direct method, second one is by using properties, third one is by using cofactors, right? You see here, A11 its cofactor, A12 its cofactor, A13 its cofactor, and their sum. This will gives you determinant of A. That is what we learned in last class, note 1. Okay, so element respect to cofactor, element its cofactor, elements its cofactor, their sum is det A. Here you see A11, its cofactor is there? No, it's capital A21. It is second row first column element cofactor. It is not first row first column element cofactor. What element is there? A11 is there. Here capital A11 is there, it is good, but it is capital A21. It is A11, this is capital A21. So we learned in note 2 in last class, this value is 0. Okay, you see A11, here capital A11 is not there, so this value is 0. You see here 21, A21, capital A11, these two are different now, so this value is 0. This we learned in last class. You see here A21, capital A21, see both are matching here, right? A22, capital A22, see this 2 matching, right? A23, capital A23, both are matching. Are you understanding or not? Yes, good. What is this? This gives the determinant of A, det A. See here A21, this is A31, different. So this value will become 0. See A31, capital A11. These two are different. So this will be 0. Sorry, A31, A21, this is 21. They are different. As they are different, what you will get? You will get 0. You see here, A31, capital A31. A32, capital A32. See here, 31, 31, 32, 32, 33, 33. So this is matching. So we know that this is det A. Okay, you observe here, this is the matrix. This is the matrix. 0 can be written as 0 into det A. This 0 can be written as 0 into det A. This 0 can be written as 0 into det A. Like that, in every element is multiple of det A here. Okay, so det A I can take common. You observe, this is not a determinant, this is the matrix, right? I can take det A common. If I take det A common, what you will get here? 1, 0, like this. What is this? You got like this. Det A into what is this? This is the identity matrix. What happened? I consider matrix A, I calculated adjoint A, and I multiplied A into adjoint A, I got det A into I. So what is this theorem statement? This theorem statement is A into adjoint A equal to det A into I. So I proved that A into adjoint A is det A into I. Similarly, you can write directly like this. Similarly, we can prove adjoint A into A is det A into I. Okay, you see A into adjoint A is det A into I, adjoint A into A is also det A into I. From 1 and 2, what I can write? A into adjoint A equal to adjoint A into A equal to det A into I. I hope you understand this. This is one of the important result we use frequently while doing objective bits, right? Now we will move to next definition. Singular matrix, non-singular matrix. A square matrix A is said to be singular if determinant of that matrix is 0. A square matrix A is said to be singular if det A is 0. To decide a square matrix A is singular or not, we will just calculate its determinant. We know that determinant is defined for square matrices only. For an example, you see there is a matrix A like this. Is this matrix singular or not? Just calculate det A. Det A. You know how to calculate determinant of 2 by 2 matrix. 1 into 8. 8 minus 4 into 2. 8. 8 minus 8 is 0. Determinant of this matrix is 0. That's why the matrix A is singular matrix. Given matrix is singular. You understand. I hope you understand what is singular matrix. A square matrix A is said to be singular if det A equal to 0. What is non-singular matrix? Simple. Non-singular means not equal to 0. A square matrix A is said to be non-singular. See here some mistake is there. A square matrix A is said to be you write here non-singular if det A is not equal to 0. Right? How to decide a matrix is non-singular or not? Here they given one matrix. You just calculate det A. If det A not equal to 0, then we say it is a non-singular. Right? Calculate det A. 1 into 1, 1 minus 4 into 2, 8. 1 minus 8 is minus 7. Minus 7 is not minus 7 is not 0, right? It's a non-zero number, right? So what we say, determinant of A not equal to 0, therefore I can say that this A is non-singular matrix. You just correct here, a square matrix A is said to be non-singular if det A is not equal to 0. I hope you understand this. Now we'll enter into exercise problem. This is exercise number 4.5. First two questions I am doing in this class. Find adjoint of each of the following matrices. This question is given. This is 2 by 2 matrix. We need to find adjoint of this 2 by 2 matrix. We need to find adjoint of this 3 by 3 matrix. First, I'll do this first question. To calculate adjoint of this 2 by 2 matrix, first I'll take given matrix as A. I am taking given matrix as A. 1, 2, 3, 4. See, for 2 by 2 matrix, directly you can write the answer. Directly you can write the answer. Nothing to worry. In NCERT textbook, this shortcut is specified. So in PUC, you can write this answer directly, or else in last example, I did as per the definition method. What is that shortcut method? To calculate adjoint of 2 by 2 matrix, simple. You interchange these two elements. Here 1, 4 is there. Now you write 4, 1 like this. Right? Interchange these two elements and change the sign for these two elements. Here plus 2 is there, now minus 2. In case here minus 2 is there, you will write plus 2. That's it, right? You change the sign of these two elements. Here plus 2 is there, minus 2. Here plus 3 is there, here minus 3. That's it. That much simple, right? Now we'll calculate adjoint of this matrix. See, adjoint of this matrix we discussed in example. So this is the second problem in the exercise. As per the after completion of the adjoint of a matrix, I explained one example of 3 by 3 matrix. That same problem, this problem, that problem, both are same, right? First, you take the given matrix A and you write cofactors of each elements like this, cofactors of each elements. To do this, simple thing is first go with this plus minus plus minus plus minus alternate symbols, right? Like that. Afterwards, you write minor of respective elements, minor of respective elements. Okay, minor of respective elements. After that, you simplify. What you will get? You will get cofactor matrix. You transpose it, transpose of cofactor matrix, that will gives you adjoint. I explained all these things in the example. That example and this problem both are same. I hope you understand this class. In next class, we will learn how to find inverse of given matrix. That is most important. How we will calculate inverse of a given matrix. Right. Thanks for watching. Have a great day. Bye bye.